Okay, what we're working with today is we're beginning to talk about and learn about linear functions. Oh, there we go. Okay, a linear function is a non-curved line. It has a constant rate of change, which constant means it doesn't, it always is the same. So the numbers will always be continuously changing at the same pace. Okay, and it looks like a line. And so it's a straight line. And go left, right, and go up and down, and go this way. Those are all linear functions. It is usually written in the form y equals x. I have no exponents. I'll have, what else? I'll have no fractions, like I can't have the x on the bottom. I can't have any root signs, anything like that. It's just a straight y with an x, and then there's going to be numbers there, and a lot of times a number's going to be in front here, and a number's going to be at the back here. So a number usually multiplies, and a number adds. Okay, but there's no exponents, and there's no x on the bottom, and there's no square root. All right, so let's look and see what happens with this one. This one right below us is a linear function. So to get from -2 to 1, I add 3. To get from 1 to 4, I also add 3. 4 to 7, add 3, and so on. So if you notice, the x's always change by the same amount. Now, in order for this to work, the y's also have to change by a constant amount. It doesn't have to be the same as x's. It just has to be the same the whole time for y. So to get from 8 to 6, I'm -2. 6 to 4, I'm -2. And so each of these are -2. And so since both of them have a constant change, that's called your constant rate of change, then that is a linear function. And that rate of change is called the slope. And we will spend some time talking about slope later. All right, so let's look and see what a nonlinear function looks like. And a nonlinear function, it does not have a constant rate of change, so it changes. Let's go green. And nonlinear forms have many different ways. So it could be y equals x squared, y equals x to the third. It can have any exponent here. It could have the x on the bottom. It could have square root of x. So there's lots of different ways that you could have nonlinear form. Okay, so let's look and see what happens with the rate of change. So this one, add 1, add 1. So the x's have the same rate. The x's increase the same each time. But remember, in order for it to work, both of them have to do the same. So this one starts off by adding 1. Then add 2, and then 4, and then 8. And so if you notice, it's changing. Okay? And so it's changing, so this is not a linear function. There is a different pattern this one has. This one actually multiplies by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, and so forth. But linear has to be adding. Linear is not multiplying. This is something else that we'll get to. Okay? So it's linear if you have the same adding or subtracting for the x's and the y's. Okay, so let's look at the next couple terms. Discrete domain and continuous domain. We talked about domain last time. Remember, domain is x, so that's the x value. Discrete means it's very specific. A set of input values with exact values. The function is discrete if it cannot have answers. If there's answers that don't exist, then the function is discrete. And once we get to some problems, it's going to make sense. And I'm actually going to change that from exact. I think there's a better word for it. It has specific values. You're only allowed to get some things. Okay, let's change that. I think that makes a little bit more sense. A continuous, a set of input values that consist of all values. So I can plug anything in and I'll get an answer. For discrete, I can't plug every single number in because some numbers aren't going to make sense. A function is continuous if it can have all answers. Okay, so a discrete domain is going to be something like this. There's no space in between. Okay, a continuous domain is that every answer exists. Everything works, and so it actually makes a straight continuous line. Discrete, there's nothing that would actually work to go there. And when we get some word problems and some situations, it'll make more sense. All right, so let's see if these are a function. So what I want you to do is I want you to find the constant rate of change for the x's and for the y's. And if they both have a constant rate of change, then it's a yes. So go ahead and try that, and when you think you're ready, press play. Okay, so plus 2, plus 2, plus 2, so that's yes. This one's minus 3, minus 3, minus 3. So yes, this is linear. All right, let's look at the next one. Negative 3 to negative 9, that's a plus 4, plus 4, plus 4. That works. Plus 3, uh-oh, this one goes minus 3 and then minus 5. So because these are different, this is a no. And it says explain why. You could just say why values are not constant. We should probably say change in y. Change in the y values are not constant. Okay, so now let's look at the next two. If it's a line, well, that is a straight line, so that's yes. This one is a curve, so that's why it's no. Can't have a curve. All right, so 5, 6, 7, you're going to have to look at your rules up here that we talked about. So no exponents, no over x, no, all those things right here. This makes it not a function. That makes it linear. If you get any of those things, it's not linear. So why don't you try 5 through 6, and when you think you have it, press play. Okay, so I have an x, I have a y, and I have numbers, so that's okay. Here, this is bad. No exponent, so no. Y squared, that's what's wrong. This one, it looks okay, but I have to actually distribute, and watch what happens. When I distribute, 4x times x becomes 4x squared, and then 20x. The 20x is okay. It's this squared that's wrong. Okay, so now what we're going to do is we're going to look at some that are discrete or continuous and decide what it is. And so right here, what's going on is you're buying tickets. And adult tickets are $4, children's tickets are $2. Well, here's an example where I have a specific amount I can plug in. My domain is going to represent the number of tickets. And so I can only buy whole number tickets. I cannot buy part of a ticket. And so because I can only buy whole number tickets, this is a discrete function. You cannot buy half of a ticket or 1/3 of a ticket or 3/4 of a ticket, so it makes it discrete. Okay? Over here on this side, I'm talking about cheese. And for this one, the domain would be how much cheese I buy. There are two different amounts, but it doesn't really matter which one I look at. I'm just going to look at Swiss right now, how much cheese I buy. Well, I can buy 1 pound, but I can also say I want 1.05 pounds. I want 2.78 pounds. I can buy any amount of pounds I want. And so because all of the decimals are represented in this and I can buy parts of a pound, this is what a continuous graph would look like, or a continuous function. Okay? So when you have discrete, it's very specific. I cannot buy parts of things. When I have continuous, I can buy parts of things to find my answer. All right? So remember to go up here and look when it's linear versus nonlinear. And that's what your main function to do today is figure out how do you know if it's linear versus nonlinear.